Hello students, a very warm welcome to this gravitation lecture number 13 on concepts and problem. And of course today we are going to get started with one of the most interesting topics in gravitation potential, and this could be one of those topics that can typically appear in your exam. Okay, you can be asked questions in terms of graphs, or kind of a theoretical question in your JEE Mains and JEE Advanced from this specific topic. You need to specifically understand few things and also admit and agree, move along few of the things. Okay, there's nothing to kind of memorize in it, but it's a very easy topic. We'll get into this amazing lecture and we'll start understanding things. Today we are going to definitely deal with one of the most interesting topics around gravitation potential. And yes, upcoming lectures are really important because a similar trend has been observed in electrostatics as well, where you're getting questions from this part of the topic. All right, and that being said, students, I am Muralidharan Gopalakrishnan. I completed my MS in Electrical Engineering from one of the top-ranking American university. I'm also an IIT who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams, and I filed 25 patent applications on state-of-the-art technology in India and abroad. And yes, I have a track record of winning several national level science and tech competition. And students, if you are looking for a complete package for your JEE Mains and JEE Advanced preparation, it's going to be Unacademy subscription. So on Unacademy subscription, we have aggregated the best educators across the nation on this one single platform, where you get to attend everyday live interactive classes with them on a very interactive platform with polls and leaderboards, so that your learning becomes super interesting. And not only that, every Unacademy subscription program is a structured program. It comes with a lot of live doubt clearing sessions. It's in fact you don't have to plan for your JEE preparation in a very systematic manner, be it a single course is concerned or be it the total program is concerned. Everything is taken care on Unacademy subscription platform. Every fourth session is going to be live doubt clearing session, and similarly you will have dedicated quizzes and mega quizzes. Yes, you will also have dedicated doubt clearing classes so that you don't have any more doubts in your mind. And not only that, Unacademy subscription comes with test series that is quite important for your JEE preparation. So they are going to be all national level test series, so that you can assess your position and improve upon your mistakes. And yes, of course, you'll be getting analysis along with them. And that being said, how do you avail Unacademy subscription? First of all, download Unacademy learning app if you don't have one, or get onto the website, log in, click on the left hand top corner extension bar, choose plus, and then choose IIT JEE as your goal, and then hit on this get subscription button. And students, one more important thing, Unacademy subscription has another amazing thing, that is like all you need to do is avail one subscription and you will be able to get unlimited access throughout the period. You can access programs for both JEE Mains and JEE Advanced at this single price. Yes, that is the amazing thing about Unacademy subscription. As long as you have the subscription, you can attend as many programs as you want. There is no batch restriction, etc. on Unacademy subscription platform. And coming to the pricing part, Unacademy subscription is quite economical. Hello students, hi. So it did temporarily, there was a power outage and session got disconnected. So yes, I was saying that yeah, if you're looking for a complete package or a champions tour for your JEE preparation, all you need to do is log in to your Unacademy learning app, click on the left hand top corner extension bar, choose plus, choose IIT JEE as your goal, and then hit on this get subscription button. It's one subscription, unlimited access throughout the period, so there are no batch restrictions. You can join any of the batches that you like, and you can pursue courses for either JEE Mains or JEE Advanced, depending upon your aspiration and preparation. That being said, coming to the pricing part, how much does Unacademy subscription cost you? All it is going to cost you is just a moment. I think streaming is on. Okay, I was just saying that the streaming is not going on, as if it's not going on. Okay, anyway, I was saying that when it comes to the pricing of an academy subscription, is quite reasonable. If you look for 24-month subscription program, which is typically like recommended to students in 9th to 11th class, because since it's a 2-year long journey, it comes only at a price of 50,400. Yes, only 70 rupees a day is what you have to pay for an academy subscription. Yes. And coming to 12-month subscription, we typically recommend the subscription for students in 12th class and long term, and this comes at a price of only 34,650. that's like less than 2,900 per month. Yes, students, it's very reasonable, and this is about plus subscription. And we have something beyond plus subscription as well, which is known as iconic subscription. And if you can afford it, this is one of the best things for your JEE preparation, because what do we have on iconic subscriptions? We have IITians and NITians giving out expert guidelines for JEE preparation. So think about it, they are already the students, like the alumni of IITs and NITs, and who have been the students and JEE aspirants who have cracked IITs and NIT before. So like JEE Mains and JEE Advanced before, so they typically know the roadmap to the success, and they will be guiding you throughout this journey. They will be giving you important insights, and as well as those strategies and the do's and don'ts to perform in your exam, and as well as the things that you should not be doing in your exam or during your preparation, and the things that you should be doing during your preparation and exam. So that's some of the important things that will be taken care on iconic subscription. Along with that, you will be getting like frequent test analysis, and as well as your personal study planner and one-on-one mentoring from IITians and NITians, only at the price of 58,500 if you go for a 1-year subscription. And if you go for a 2-year subscription, it's going to cost you less than 50,000 a year. That's like 45,000 per year, 90,000 for 2 years. Yes, of course, if you can afford it, it's one of the best things for your JEE Mains and JEE Advanced preparation. And coming to the pricing part, this is going to coming to the pricing part, make sure you apply Murli Live code so that you get the best discount, be it on plus or iconic subscription. So these are the prices after discount. So to avail the best maximum discount, make sure you apply Murli Live code, be it 6 months, 12 months or 24-month plus or iconic subscription. Okay, let's not wait anymore. Let's get into this interesting chapter of gravitational potential. And coming to this, this part of the gravitational potential, see, some of the things, whatever I'm going to, teach you, you need to understand that, admit that, else it does not work. Some of the things, there is a reason, few things are like, that's how it works. That's how it was proven by, proven by the scientists who were working around it. So that is how you have to assume as well. All right. So the gravitational field at a point, I think this should have been a gravitational potential. Anyway, this is a gravitational potential at a point P at a distance 2r due to the spherical shell with radius r and m uniformly distributed throughout the surface. So we are talking about gravitational potential, and this is a point P which is outside the shell, and this shell has mass m uniformly distributed throughout its surface area. Now the question arises, how do we find out the gravitational potential in such situation? And of course, most of you do know the answer, I guess. And anyway, before that, let me come to the concept. So this is how it works, students. See, be it solid sphere or a hollow sphere or a shell. So this is a shell. It can also be a solid sphere for any point outside the shell. Okay, if there is a point outside the shell, what do? We say that all of the masses is all concentrated at the center. Okay, whatever is the mass of the shell is concentrated at the center of the shell, and then you would be measuring this gravitational potential for this point mass. Okay, this gravitational potential for the point mass, right? That's how it works. Yeah, that's how it works. So it's a really simple thing. Let's say it's r, and the condition is r should be greater than r. Do remember this, r should be greater than r. Even if you remember during gravitational field, we discussed the same thing. So now in this case, what is your gravitational potential going to be? Your gravitational potential is going to be something like we call this as Vg. Let's call this as Vg minus Gm by small r. Okay, it has nothing to do with the capital R. It is as if all the masses are concentrated at the center, and of course, as you understood, the maximum potential would be on the surface because the R is going to reduce. And what happens beyond that is something that we'll be discussing as we move into this lecture. Okay, so in this case, what it is, it's 2r distance. So what should be the gravitational potential for this shell? Or it need not be necessarily be shell, it can also be a solid sphere. For a point outside the solid sphere, it's going to be how much? Minus Gm by r. In this case, r is how much? 2r. I believe this should be super clear now, right? That is how it works. Okay, all the masses, why do we say this? Because all the masses are concentrated at the center, right? We'll assume all the masses are concentrated at the center, so it's a point mass with mass m. Good evening, Amrit. Good evening, 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 everyone. And that being said, so this is valid for which all conditions? Two things we discussed. Okay, why am I discussing this? We won't be discussing the other thing. That's the reason I wanted to discuss and close this. Rather, I'm just going to talk about the one in the square. This is for r greater than radius. R greater than radius. That is any point outside the shell or sphere. Okay. So that's like any point. Very important, students. It's a very basic concept. Outside, let's call it as the shell or the sphere, or the shell or solid sphere. What are we trying to assess? We are trying to assess the gravitational potential at point P. That is it. That's the end of the story. It's really that simple. There is nothing hyper complicated in such cases. Okay, well, let's do a thing. I hope you understood this concept. So even if it was a solid sphere, it's going to be the same thing. So let's do a thing. Let's get into some other interesting. So now there is a solid sphere, and you have a point on the surface, and this solid sphere has a radius 2r. Okay. And there is a hollow sphere, and the sphere has a radius r. Now, what is being asked? So let's say how the question would be asked in your exam. Question would be asked in your exam about two things. One might be your gravitational potential, and the other might be gravitation. Okay. We'll discuss both of the things as we move into this problem. Now, what is the gravitational potential at point P? At point P, due to both of this, solid sphere and the hollow sphere. Both have mass m, and it's a point outside solid sphere and hollow. Now, in such situation, what are you supposed to do? The scalar quantity. Alright, let's get into this point. So, we have already discussed this thing. For any point r greater than r or r greater than equal to r, what is the gravitational potential? Gravitational potential is minus Gm by like small r. In this case, the small r is, in this case it should be 2r, right? 2r, because 2r is the radius of the sphere. So that's just one of the conditions. Leave this is here. Okay. So this is going to be minus Gm by 2r. Okay. For any point, it can be this point just on the axis of both the spheres, which is a coaxial point, etc. Still, it's going to be, the potential is going to be this. It does not have any direction. Now comes the question. For the other one, for due to the blue one, you are going to have one. Due to the orange one, you are going to have. Let me do a thing. Now let me ask you a question. What do you think is the field at this point? It's a very, 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 very interesting. What is the field at this point? So point on the axes of the solid sphere and the hollow sphere, the field is going to be 0. The net field is going to be 0, right? But there still exists a non-zero potential. Okay, surprisingly, this point there is no, field, but this point does have potential. Okay, agreed, because see, field is 0, you know that gravitational potential is a scalar quantity. Let me do a thing. Okay, what we are going to do is, we are going to call this as sphere S1, this is sphere S2. So how do we find out net gravitational potential? Just like how we did earlier, even for the point masses, the same way you'd be doing even over here. So let's say I am to find out the net gravitational potential, which is a non-vectorial quantity. So I'll be adding potential due to sphere 1 plus that of potential due to sphere 2. Potential due to sphere 1 we just discussed. In this case, it's going to be minus gm by 2r. And potential due to sphere 2, what it is going to be? Again minus gm by 2r, because this has a radius r, it's on the coaxial point. Okay, this 2r should have been the thing, but it's not, like up to the scale. Just assume it's like, it has been not drawn up to the scale. So this distance is how much? 2r, which is greater than that of, okay, this is not of course the max potential in this case. Okay, know that thing. I am assuming so. We need to calculate. I'm not sure, but I'm thinking this should not be the max in this case. So this would be how much? This is an r greater than r. So this is an r greater than r, which is nothing but the radius of this hollow sphere. This is going to be minus gm by 2. See, the concept of this question was, the field at this point was 0, but okay, you add them both, 1 by 2, 1 by 2, it becomes 1. Okay, minus gm by 2r plus of minus gm by 2r, it's going to give you how much? Minus gm by r. That's easy. Okay, and is this 0 or non-zero? It's non-zero. Whereas your gravitational field is 0. Field is 0. That means any point mass placed at this position P would not experience any force. Field is 0, whereas potential is non-zero. Very interesting, right? It's totally possible. Agreed? Now let's come to the concept. Okay, this is the concept. This is the end of the question. So now we have one more such question. Okay, the gravitational potential at a point P at a distance r by 2 from the center due to the spherical shell with radius r and mass m uniformly distributed throughout its surface. The same spherical shell that we saw earlier, it has mass m, radius r, but this time we have to find out the gravitational potential at a point inside that hollow shell. This is a very interesting problem. So what is the field inside? 0. You think gravitational potential is also 0? Does this thing come to your mind? If that comes to your mind, you have a good question. But we just discussed a similar problem, right? Where field was 0, but gravitational potential was not 0. Exactly. Even in this case, gravitational potential is not going to be 0. So let's say you have a point inside. Okay, just like how we saw in the earlier case. In this case, it's r less than r, radius of hollow sphere. Let's be very specific this, and you need to understand this even better. So in this case, what have you observed? In this case, you have observed that there isn't any, gravitational potential. Sorry, there's no field at this point. So what about the gravitational potential? Is it also going to be 0? At this point, no field exists. As simple as that. But we know something. What do we know? We know gravitational field is equal to minus dV by dr. Okay. So basically, the difference in potential is 0. It's not the potential is, right? That's it. Anyway, you know, inside any point r less than r, in this case, it's going to be 0. If it is r less than r, then in this case, how do we derive this? We say that dV is equal to 0, but we know there is a potential on the surface. The potential on the surface is equal all inside the sphere, then only field does not exist. Then only a particle or a mass inside that shell would not experience any force. Simple as that. So we know dV is 0. Okay, we can write something like delta V is equal to 0. That also implies at this point P, and let's call another point, okay? I'm going to call this as surface point S. Okay, we know dP minus ds in this case is delta V, which should have been 0. If that was 0, that implies, first of all, Vp is equal to Vs. Now you know the potential inside the shell. If you know this thing, what is correct? Correct that thing that we did earlier, that any mass or any particle, any point mass would not experience gravitational field. So it should be uniform mass distribution, right? Gravitational field inside a hollow shell, or a shell itself is hollow. Okay, inside a shell with uniform mass distribution. Very important. Uniform mass distribution, if you miss out, nothing is applicable without uniform mass distribution. It's really simple. This thing is very obvious. This is simple to understand. So what should have been the answer? Vp is equal to Vs. That should be minus Gm by R. Okay. So for any point inside, it's not minus Gm by R by 2. If you have made that mistake, do correct it. But we have that option. For this point, it's going to be minus Gm by R, which is same as surface potential, right? And for what condition? For R then radius of this, you know this thing. Simple as that. Okay, but it should be uniform mass distribution. Even in the case of field, if it's only 0 field, if it's uniform mass distribution. Easy. Alright, now let's come to the one of the most important and interesting part around this topic, that is graphing around like gravitational field for a hollow. Okay, what are we doing? We're going to graph for a hollow sphere, or you can call it as a shell with uniform mass distribution, of course, everything we are generally typically discussing uniform mass distribution, else you will be deriving the function and working accordingly. Okay, let's do a thing. What we are going to do is we are going to only calculate for the magnitude. We are not going to consider the sign. If it's sign, the graph has to be on the other side. Okay, but that is negative because why? Because it's an attractive force. No other reason. Call it now comes the point. We have potential. Okay, and what we are going to do is say this is, let me do a thing. Whole thing r. Okay, this way also it's going to be negative r. The graph would be just a mirror reflection. This is the most important part, or this is one of the most important parts that you. Okay, now comes the thing. What is this? This is a y is equal to 1 by x graph. Okay, this is going to be y is equal to, everything, I guess. It's pretty damn easy. Something like that. Not like a linear curve. It looks, it's little different than 1 by r square curve than your field curve. Going to not vary so much with x, but it's going to vary. Now this indicates this is all constant. This is that inside point, any point from here to here, that constant. And then beyond that we have this other graph, which is basically indicating y is proportional to, and this comes from, even if you understand this graph, it's good enough, student. Good enough even if you understand. Okay, and similarly there would be a mirror reflection on the side for the other any points outside the sphere. Okay, but anyway, we are just considering one r as the x and think about it. Just think about only one r exists, and it's all radial directions that we are calculating. Alright, it's a very simple problem. Let's move on to the next one. Now comes one of the most interesting part. So I think we have done a very similar problem earlier, during your field. Okay, now you of course know field is varying inside a solid sphere. Okay, what is being asked? The gravitational potential at a point P at a distance r due to the solid sphere with radius r and mass uniformly distributed throughout the volume. And this time this r is r by 2, which is inside that. So how do we work for such question? See, one of the ways of understanding is there are multiple ways of doing it. I really like to go with the easiest one. So the easiest method would be what easiest method would be to take two parts. Okay, there one part during a field, whichever was outside this point P, did not have any field effect. But in this case, in potential, it's going to have. It's basically bunch of shells, varying from distance r to r. And then outside that is a inside that point, or for the point that is outside for it, it's a solid sphere. Okay, let's get into this. It's pretty easy. So basically two parts. You need to divide such question into two parts. it can be many times, students, probably what I am expecting, it wouldn't be like single the simple uniform mass distribution question. It can be a non-uniform mass distribution, where the non-uniform mass distribution is throughout the volume, it's non-uniform mass distribution, but it has uniform mass distribution at every hour. In that case, everything is applicable. All you need to do is understand the method and apply integration. Gravitation, 1 or 2 questions, but the easy 1 or 2 questions is going to be gravitation. It's very similar to your units, dimensions and measurements, and a very interesting topic. Okay, that is, and I would say now what matters is easy topics, completeness in your preparation. Of course, yes, these are the 2 important things to do. Easy topics, high weightage topics, easy topics, completeness in your preparation. Because they are going to influence everything from now onwards, because that is the most important thing when it comes to it. Because you have multiple papers, right? If you have noticed electrostatics, questions have been asked from the topic that have never been asked before in JEE Mains or JEE Advanced in year 2019 and 2020. Similarly, you'll observe the same thing in current electricity. In fact, today we are going to get started with current electricity PYQs, which is going to be super interesting, so do not miss it out. Today we are going to discuss 2020 questions, and you'll see it's like literally the easiest current electricity, except for few questions which are little time consuming, like the easiest paper ever, like for current electricity. But I think it's really a very good topic to complete. Okay, and gravitation, of course, students, like 1 or 2 questions. I wouldn't say a heavyweight topic, but a easy scoring topic, where you need to attend only few lectures and you'll be able to understand the concept and you can maintain the completeness. Only few things are left. We need to do, like, gravitational potential. We'll be doing a lot of problems depending upon what is being recently asked in your trend, what is in the trend for your examination. And then we have gravitational potential energy, and then we have Kepler's law, planetary movements, etc. And that is also very important point. How does the gravitational field vary with distance inside and outside? It's the same kind of thing for your solid sphere. So let's get started on this. This is a part outside the solid sphere. Okay. And this is a part inside the solid. You might come across different ways, but I'm going to discuss the easiest, intuitive and most practical way to solve this problem. Even given any kind of different mass distribution, you don't have to get confused. You can make use of it. So what I'm stating is a very simple thing. So what I'm going to state, see this point, like this part of the sphere is nothing but a very thick shell, which is a very thick shell. And this thick shell, okay, let me read this. You need to understand it little differently. It's very easy. It's very simple. So this is a thick shell, like very thick shell, not a thick shell, but a very thick shell. I would say, like, because you're going to integrate it, find out the impact at point P. Okay, let's call this as a point P. And this inside thing is what? It's basically a point on a smaller solid sphere. So basically a point on solid sphere, gm by r, where r is the radius of that solid sphere. That's all you need to know. Only 2 things. 1, 2. Similarly, let me give the same numbering for there as well. The thing that you need to definitely understand. So let's do a thing. Due to the solid sphere, right? Like, I'm going to call this as V inside. Okay. Potential at point P due to the sphere V inside, and this as potential due to a very thick shell. You add them both, you'll get the answer. Very simple. It's basically Vp is equal to Vo plus of Vi. That's it. Now, since you know it's a uniform mass distribution, you need not worry about rho. And guys, definitely if you get in your exam non-uniform mass distribution, use the rho given in the question. Okay, rho can be a function of R. Okay, so in this case, what is the rho? Rho is nothing but a constant value, which is going to be in this case mass of the solid sphere divided by the volume of the solid sphere. Going to mass divided by 4 by 3 pi r cube. Let's keep it aside. These two things you need to know. Just let's keep them aside and start working around the problem. We are going to express everything in terms of rho and finally come up with a value and then substitute the value of rho and see what should be our final expression. And from this expression, can we conclude something about how we are concluded for your hollow sphere? Very simple. So let's get started with this part, that is the outside shell, outside thick shell. So okay, before we do that, let me quickly take you through what you're going to do. I'm going to consider a very thin shell. Unlike our thick shell, I'm going to consider very thin shell. And this thin shell makes up for multiple thick shells. Okay, this thin shell makes up for multiple thick shells. So we have thing that we need to do. What is the thing that we need to do? We will assume this is at a point X. Okay, and this X is varying from where to where? This X is varying from small r to capital R. For now, just assume this to be small r, not r by 2, but small r. It varies from small r from here to radius, of course, of the sphere, but capital. So we need to integrate this thin shell. What is the potential due to one thin shell? Let's assume this thin shell, right? It has some thickness, right? Not like very super thin that it does not have thickness. It has some thickness. Okay, some thickness like dr, and that also corresponds to it having some mass dm. Okay, we need to express the value of dm in terms of dr. First of all, let's do that. We know the potential value. It's very simple. It's basically minus dm by r. In this case, we need to find out that dv and integrate it. That's it. Okay, so what is dm? Dm is, it's a shell. Shell will be having a surface area 4 pi r square. In this case 4 pi x square, my mistake. So let's change everything to x, x and x. Okay, dr we can take it as dr and do that as well, but already have an r, right? Better rather we take it as x and the surface area is 4 pi x square. So what is going to be the mass? Density into volume, which is nothing but of that like that small shell. Okay, so let's not use v. Volume, some differential volume. What is that volume? This in this case is going to be 4 pi x square surface area into thickness dx. You got this thing? This is a constant, right? So now the thing is, what is the potential? Potential due to that small shell, I'm going to call it as dv potential at point P for now. Or let's say this as, we used to call this as d, the total potential as V outside, right? VO, we'll call this as dVO. And this is going to be how much? Minus G dm by x. Or how much? X, that's it. Nothing to do with x minus r, etc. It's basically x at that point. Irrespective of anything, it's just like if you remember in that thin shell case, what it was, gm by r, right? Similarly, it's gm by x. In this case, it's g dm by x. That small mass, like not the small mass, but the differential mass at the distance x. Substitute the value of dm from here. What would you be getting? G rho 4 pi x square dx divided by x. 1x is left over. So only 1x is left. 1x and 1x gets cancelled out. So we have like g rho, which is constant. We have 4 pi x dx. Okay. So we are calculating for outside. To find this outside, what are we supposed to do? To find the total potential outside, we have to integrate this dVO. Inside is very easy, trust me. You know how to do it. There is nothing in inside. Definitely, it's very, very easy. This is going to be how much? Minus 0 4 pi x dx. We need to integrate this from r to capital R, small r to capital R. Okay, it's basically saying that, you know, we are taking that mass. It's not like we are calculating. Basically we're calculating for each such, you know, like a small, like small, thin. That's it. So there you go. It's a very simple problem, students. It's 4 pi g rho is constant, and we have x dx going from where to where? R to capital R. X dx integration is going to be how much? You know that thing. It's going to be x square by 2. Differentiate it if you have issues with this kind of things, right? Differentiate one increased value such that it comes to you know, this value. Okay. Oh, this is very simple. There's no issues. Easy problem. Right, that's it, students. That's all about it. So we are going to substitute the value and get the final result now. This was also VO. So let's do that. It's going to be minus 4 pi g rho. This is like r square, like capital R square by 2 minus of small r square by 2. And we would be adding this potential, right, inside and outside. We are not going to like you know, do it like, you know, something. Anyway, you will be understanding that's a scalar quantity, right? So this is due to that thick shell, right? Like, you know, that outside you can say shell here, like outside semi-hollow sphere, due to outside part of the sphere. Okay, we have one, and then we need to calculate the other. We know what is the other thing. It's a very simple one. So you know rho. Okay, you know what is this? Is really simple? What, you know rho? What is the mass of this? This is basically like 4 by 3 pi r cube. If I'm going to calculate the mass of this, like, you know, inside thing, it's basically rho into mass is how much? Rho into 4 by 3 pi small r cube. That's it. So let's call it as M inside. So what should be your potential inside? It's basically minus G M I by now in this case, whether it should be what? It should be smaller, right? It's a point on the sphere. So this time this R is like R by 2. Some R by 2, R by 3, R by 4, etc. It's in like just a point on the sphere. From outside, you must be thinking you just came onto that sphere. That's it. That's it. That's it. That's it. It's a very simple problem. So this is going to be how much I'm going to substitute the value of mi and write it down directly. It's 4 pi. I'm just segregating the constant term, like 4 pi 0 divided by 3, and you have r cubed by r. Of course, one r is going to get cancelled. You're going to get r square. Okay, let me write it down over here. I have two terms. One is v inside. Okay, we got this to be minus 4 pi g rho by 3. You have to do it once yourself, students. You can start taking down the notes. Basically, note down the concepts, and once you go home, especially students who are getting started with gravitation, you need to do it yourself once. That's when this would become clear, and you definitely need to do this. What if it's a varying density, mass density? Okay, so definitely you have to do this. That's it. We need to do a very simple thing. Add outside and we have nothing more to do. We could potentially do one more thing in both of these calculations, that is substitute the value of rho and carry out. Let's do a thing. Let's take the final value and substitute the value of rho. Okay, so I'll definitely show you both the values, and I'll even highlight them. What you need to do. Okay, let's move on then. So net potential is equal to potential due to this outer sphere. Okay, potential due to the outer sphere, any point outside, and due to the inner sphere. You add them. Okay. So now what was due to outer sphere? If you remember, it was minus 4 pi 0 r square, capital R square, minus small r square. Okay, minus 4 pi 0 capital R square minus small r square by 2. Okay, integrated, so there would be a 2, right? Minus 4 pi 0. We're going to do a thing. Let's keep it as capital R square minus small r square by 2. Then we'll substitute the value of r by 2. And what was inside? Inside was very simple, right? It was basically g into rho into 4 pi by 3, r cube. That's it. Divided by basically that small mass divided by r. So one r would have been cancelled out, and you would be having something like again an r square. We quickly jump back to the value. This is the value. Plus 4 pi 0 by 3, and you would be having a r. Okay. Easy. Now that's it. Now what you need to do is take out minus 4 by 0 as common. Very simple way to do it, because rest would be complicating it. Minus 4 by 0 as common. This would definitely make, if you keep noticing it, you would be having like brackets. Okay, 1 by 3 and 1 by 2 would be there, so we can't help it. And we can finally substitute the value of rho, try to get an expression in terms of m. Going to be, what is rho? M by 4 by 3 pi r cube, capital R cube. Okay, let's do this. This is going to be r square minus r2. This is again plus because we have taken out the minus out as common. This is going to be r square by 3. So it's basically minus r square by 2 plus of r square by 3. Do we have any more manipulations to do? We can probably keep the value that way itself. Isn't it? So it will be like r square by 6. Isn't it? Going to be minus 4 pi 0 g rho, or rho as in density rho. Going to be r square is going to remain as r square by 2, and here this is r cube, r square by 3 minus of r square by 2. This is going to be r square by 6. We can also get that, expression like 3r square by 2 minus r square. So in this case, if I ask you what is the potential at the center, it's not 0, right? It's some non-zero value. If you substitute it directly, we'll come to know that. We'll do that as well. Okay, but first of all, let's get an expression in terms of m. Okay, this was all what we net up until now. We can either you don't have to remember it. If you can remember it, that's really good. Okay, but if you can't remember it, you must know how to quickly get to this value without any confusion in your exam. Okay, so we are going to substitute all the values to get the final result, and this is rho. Okay, the rho was what? Minus 4 by 0. Rho was m by 4 by 3 pi r cube. 4 pi would get cancelled. Okay, and then inside the brackets we have r square by 2 minus small r square by 6. Okay, so we have something like okay, actually this 3 can be taken, and okay, we can get the expression, like the kind of bookish expressions that you come across. That is also possible, I guess. That should be possible, right? Both should be yielding the same. What's the point of doing this? So minus 3 gm by r cube. This is going to be r square by 2 minus r square by 6. That is all. Yes. So one of the things that you must have come across the book is something like this. We can do that as well. What we can do is take this 3 inside. Let me mark down this as the final answer. Whichever you are convenient with, if you can remember, fine. If you can't remember, try and understand the method. I wouldn't say it's very important that you remember, expression, but it's important actually, right? Why it is important? Because if you are noticing something, there is an interesting thing around. I'll come to that explanation as well. So before that, let's do a thing. Let's try and simplify it in terms of how we used to see in the books. So this would be like minus gm by let's keep it as r cube for now. I don't know in book whether there is an r cube. There was an r cube. So this 3, if I take it inside, right, and turn everything into common denominator as 6, we are doing this for a certain reason. Okay, let's turn the common denominator as 6. So this would be multiplied with 3. Ultimately, this 3 and 6. Okay, I'm trying this. I'll just show you the calculation. Let's keep this 3. and do something like this. R square, 3r square, 3r square minus small r square by 6. We can do this. This would come out to be. I can take out this 2 as common. That's what we are going to do. 3r square minus r square is going to. This 2 comes out to be common. Why am I doing this? Because this is all constant. While graphing, it's going to be super easy. While understanding the expression also, it's going to be super easy. That is one of the reasons to write down. So here comes the question. Where is the maximum potential in this case? Is the maximum potential at center? How much is that? That is going to be 3 gm by 2r. Okay. All right. Let me do a thing. I'll mention it over here. Okay. What is the potential at the center? Potential at the center is going to be, if you substitute the value of r is equal to 0, you'll be getting this, right? You need to substitute the value of r is equal to 0. The same expression, or you're only taking care of the first integration. Second integration is not at all relevant to you, but you're doing it from 0 to r. You can think about it that way as well. So this should be minus 3 gm by 2r. Okay, is this the max potential in terms of magnitude? Okay, this is the max potential, right? Because as we move with r, what is happening? The potential is reducing. That's it. And you can validate once you derive things like this on the surface, irrespective of anything. You should be getting minus gm by r. You substitute r is equal to r square, that is going to be minus gm by r. The maximum potential is minus 3 gm by 2r. Okay, magnitude is going to be 3 gm by 2r. And as you move with the distance, what is happening? It's reducing and coming down to eventually minus gm by r. Okay, and then it's reducing further. Okay, let's do this graph. Okay, I don't think we'll be able to accurately graph this thing, but let's try it out. Let's do a thing. Let's only deal with one axis. And this should be easy to understand. This is distance r. This is gravitational potential graphing. So I hope everyone understood this point. Else let me come back to this thing. How we did was very easy. One, we took an outside shell, one we took an inside shell. Outside thick shell that we integrated through all the like integration thing that we could do, and inside thick shell we basically multiplied with depending upon the row you need to do it. Since it was a constant density, we just multiplied the density with that inside sphere's volume, and we added them both and we calculated the potential. Okay, finally we understood the maximum potential, maximum gravitational potential. What do I mean by maximum gravitational potential in terms of magnitude? Is at the center. Okay, that is minus 3 gm by r, and this is reducing with r, right? This is I would say decreasing with r. So it was 1.5 times some value, and eventually it became just gm by r. Okay, that is it. So we would be having values over here. Minus, sorry, this no minus. We are just talking about magnitude, strictly magnitude. So this is going to be 3 gm by 2r, and this is going to be dm by r. Okay, and this is at the center, and let's take this to be whether we will be able to exactly land over here. So this would be a graph like this: r square minus r square. It has to come down. Let me add. Not a linear graph, of course. Then it falls quickly because it's r. Okay, so it's altogether a different kind of graph that you can expect. This is x is proportional to 1 by y is proportional to same thing. Y is proportional to 1 by x, or x is proportional to 1 by y, but let's keep it as y is proportional to, because in this case that is more efficient in understanding things. And in this case, what is happening? Y is proportional to minus x square. Okay, some constant minus x square. It's like some constant minus. Okay, so this graph will be coming down like this. So inside it's not zero, maximum at this point. I don't think this graph looks very nice. You should once also check out in your book. This is at r. There the maximum potential was any point inside and on surface for a hollow shell, hollow sphere or a shell. Okay, so this would be a max potential. As simple as that. I'm just going to try and graph it again. I want to look into your book. It's not a linear curve. Okay, sorry guys, it should not be like this, right? It should be falling down. It should be a parabola. My mistake. Really, that's a blunder. It should be like this, right? Yeah. Trying to graph it as a falling graph, just a custom. Sincere apologies. Be a parabola, falling parabola. Okay, my sincere apologies. Serious mistake. But yeah, do correct this. So yes, that's it. That's all about your gravitation potential. I hope you understood this point, why we did this. This is like a parabola equation that we have. Like take this to be like x and this to be y. This is something like y minus x, k minus x. So we'll be getting like something falling like this, not like this, of course. Okay, that's what I was thinking. What is going wrong? What is going wrong? Why are we getting the value? But you need to remember this thing. You can slope it out or find it, but I think we don't have to do that in this case. It's parabola. Yep, remember this. And yes, it's a very simple concept, right? Once or twice you practice it, this will become obvious. Okay, this will become super obvious to you. And do it now, so that you'll be dealing with something very similar in your electrostatics. So do practice it. And in fact, electrostatics got a lot of weightage last year in your JEE Mains. And typically now onwards, don't expect segregated weightage in your exam. It can be random weightage, but depending upon your paper, too many papers. Okay, but that might be for just 2021 aspirants. There are many more interesting problems coming up, because we have another class. We'll have to cut it short. Do definitely attend the next class, because it's going to be super interesting. We are going to get started with current electricity. We are going to solve way too many problems. Even we have many more interesting problems as well coming up in this, like how to find out. This is one of the typical things that has become like an usual thing in your exam. So we'll be solving many more problems around gravitational potential, how to derive gravitational potential from a given gravitational field, and how to definitely we'll be making use of this everywhere. From now onwards, you'll be seeing this. We'll be making use of relation of gravitational potential, gravitation field. If you want to understand this topic, try to complete this lecture and the earlier lecture. That should be good enough, but try to maintain completeness. Without completeness, your exams are going to become tough for you. If you maintain completeness, anything would become easy. Don't worry about the 100% of the paper, but worry about that pi that you need to score and get into IITs and IITs. But yeah, we will have many more interesting problem coming up in the upcoming session. And not only that, today at 7:30 we are going to get started with the PYQ session. Okay, that PYQ session is going to be super interesting because you're going to get started with current and electricity, one of my favorite topics, and as well as a very easy topic. You'll notice like it's so easy that you can solve these problems within 30-40 seconds in your exam. Literally 30-40 seconds. If you understood the concept, it's like 30-40 seconds. Only there were 2 or 3 questions. So today we will be probably dealing with the Jan session, and you'll notice that it's very easy. And we'll be dealing with them, students, so don't miss it out. Let's see how many problems go. So we have a lot of problems for this session, but let's see how many problems we are able to solve. And that being said, this Sunday from 10 a.m. to 12:30 p.m. we are going to have a problem session, a quiz on vectors. This is basically going to be part 7. Why am I calling this part 7? It's actually not part 7. It's going to be independent of the rest of the topics. We have completed all of vector, students. If you're looking for vectors classes for free of cost, they're all available on Unacademy learning app. So you can go and attend them now. You can go and attend those lectures. You can understand them from both physics and mathematics perspective. But for mathematics, I definitely do recommend you attend mathematics based vector classes, because this is only sufficient for physics. We have discussed how vectors is applied in physics. How do you work around vectors based problem? How do you apply vectors in physics? How do you do component resolution? What is cross product? What is dot product? What is scalar triple product? What is vector triple product? What is Jacobi identity? How do you leverage them in your exam to solve the questions quickly? And this Sunday we'll be discussing problems. These are going to be mix of both, mostly like many mathematical concepts, but they are just mathematical concepts good enough for your physics. So definitely do also try and complete your vectors chapter for your math, but this should be laying down the foundation for even your mathematical classes. And definitely the most important chapter for physics, students, definitely the most important chapter for physics. This is where you should begin with your JEE 2022 preparation. If you haven't started at all, so get started. All of them, like 6 parts, are available for free of cost on your Unacademy learning app. And again, this coming Sunday, we are going to have a free special class on vectors. Just we are going to solve many problems as possible. And that being said, we will be having JEE Mains 2020 problem set on electrostatics on your Unacademy learning app from 10 a.m. to 12:30 p.m. on Monday. If you have missed any on your regular sessions, try to attend this, because we are going to have it in a very interactive way with all the polls and leaderboards. So make sure you're attending them. Try and solve the problem during the session rather than completing it well before. You may want to complete the lectures over here, but anyway, we are going to get started with current and electricity. So keep track of current and electricity, the most important chapter in past 10 years. And every year you get 2 or 3 questions. Some years you even got 2 to 3, 4 questions sometimes. But you'll notice today how easy it's going to be. And yes, this is on Monday. The next following day, we'll be having a JEE Mains 2020 problem discussion on electrostatics. And that being said, we have already covered units, dimensions, and measurements. 2022 or 2021 aspirant, do not miss out this topic. Again, you have full-length lecture series available for free of cost on your Unacademy learning app. These are 4, plus there is 1 additional problem session. So complete them, because this is going to be the less time consuming, easiest topic for your JEE preparation, be it now or be it in your exam. Yes, definitely do complete it, students. It's going to be super easy. So try and complete it as soon as possible. If you're 2022 aspirant, 2021 aspirant, complete it as early as possible, because you definitely get questions from this topic. You would see past 10 years paper, there wouldn't have been a single paper without this topic. So complete them, students, complete them, maintain completeness. Very important, the most important part for your JEE preparation. And students, yes, if you do not have Telegram app, download the Telegram app from your Google Play Store and App Store and click on this link which is available in the description box below. You would see, notice a link for your Telegram channel. This is going to be a JEE English Telegram channel. So click on this link and get onto a Telegram channel. All you need to do is click onto this link, and what you get? You would get before time updates on such free of course special classes, YouTube classes, what is being discussed in YouTube classes, any kind of information from NTA news, etc. we share on this Telegram channel, and many more things. So do definitely get onto our Telegram channel. If you're not yet on it, click onto that link and join our channel. Yes, you will get before time update from our JEE English team. And that being said, students, yes, do download also Unacademy learning app. If you don't have one, just type in Unacademy on your Google Play Store and App Store, and the first search result is going to be Unacademy learning app. Install, just click on that install button. That's it. You will have the most downloaded education app. Why do you need this, students? Because this is going to give you so many free of cost special classes. I keep conducting A to Z sessions, and once you follow me, right, you will be able to get live updates. So do follow me and get the live updates on this A to Z sessions. So you will be able to get live updates. You will be able to attend many such free of cost special classes. Not only that, you can attend national level free of cost and academic quizzes. And that being said, you can also attend an academy combat from your Unacademy learning app. And the most competitive gamified IIT JEE battle ever is going to happen again on 3rd of January. Be sure to enroll to this competitive gamified learning, like IIT JEE battle with Murali live code. It's going to be super interesting. So enroll today, apply Murali live code if you are enrolling in this Unacademy combat, and we are going to distribute as usual many prizes for your Unacademy combat. This can be hundreds of Amazon vouchers. Okay, we are going to distribute hundreds of Amazon voucher, MacBook Air, Apple iPad, and also earpods. So do definitely attend them and enjoy them. Take it as a learning experience. We have dedicated programs for 11, 12 and droppers. And that being said, if you're looking for a complete package for your JEE Mains or JEE Advanced preparation, of course, it's going to be an Unacademy subscription. Why? We have the best educators across the nation on a single platform. Yes, we have got all the best educators across the nation on a single platform with whom you can attend daily live interactive classes. And not only that, on a very interactive and attractive platform with polls and leaderboards where your learning is going to become super fun, students. And not only that, every program on Unacademy subscription is a structured program. That way you don't have to worry about the planning. Everything is planned for that topic or for that entire year, depending upon which kind of program that you're attending. And yes, of course, every program comes with live doubt clearing classes and quizzes and mega quizzes. And of course, students, every Unacademy subscription, you get to attend a lot of test series, national level test series, where you get to analyze your position and improve upon your mistakes. And of course, students, that being said, how do you avail this Unacademy subscription? All you need to do is download an Unacademy learning app, log in, and click on this left hand top corner extension bar, choose plus, and then choose IIT JEE as your goal, and then hit on this get subscription button. And one more amazing thing about Unacademy subscription is one subscription, unlimited access throughout the period. And that being said, coming to the pricing part, it's quite reasonable. All it is going to cost you is less than 70 rupees a day if you go for a 24-month subscription, which we typically recommend for students in 9th to 11th class. Yes, it's a 2-year-long journey. If you are starting early, very good. That is one of the best things that you can do for your JEE preparation, one of the justices that you can do to your JEE preparation. And students, yes, be sure to apply Murali live code so that you can get the best discount on your subscription purchase. And that being said, you can also conveniently split your payments into multiple parts, and you don't have to go through the hassle of paying it all at once using our pay in parts option. We do also have access to no cost EMI on an Unacademy subscription platform, where you don't have to again bear any interest and split your payments easy monthly installments. Okay, you can split your payments into easy monthly installments without any interest. So you can split your payments into multiple parts in both of these options, and you don't have to go through the hassle of paying all the fiat months. We also have access to other payment options like debit card, credit card, UPI, etc. And if you're in long term and dropper, if you're in a long term, or if you're a dropper student, or even if you're in 12th class, so dropper, long term, same thing, and you will get your Unacademy subscription at a price of only less than 2,900, 2,888. And what do we have for long-term and dropper students? Of course, dedicated droppers batch, micro courses going on, national level test series, and the best educators and authors like DC Pandey sir, DC Gupta sir on a single platform. And make sure you apply Murali live code so that you can get to this price point, you can avail the best discount, and you can also unlock many more features on Unacademy platform using Murli Live code. So do make sure you apply them every time you're purchasing any Unacademy subscription. And that being said, students, this was all about Plus subscription. We have something beyond Plus subscription known as Iconic subscription. And what do we have on Iconic subscription for you? We have everything that you have got on Plus subscription. Along with that, you will be getting personal coaching and mentoring from IITians. So think about it. You will be learning from IITians, not only learning from IITians, but also getting expert guidelines and one-on-one mentoring from IITians and all the strategy sessions, do's and don'ts for your JEE Mains and JEE Advanced preparation. And of course, students, you will also get study planner and etc. On Iconic subscription, many more features than your Plus. And if you can afford it, students, it's one of the best things for your JEE preparation. For a 12-month program, you would be paying only 58,500, and for a 24-month program, you're going to pay like less than 50,000 a year. That's going to be 90,000 for 2 years. So make sure you're applying Murli Live code while purchasing Iconic subscription. As you know, that would give you best maximum discount on your subscription purchases, be it Plus, Iconic 6 months, 12 month or 24-month program. Make sure you're applying Murli Live code. And that being said, as you know, our team is right now on Iconic subscription. Now you can take your JEE preparation to next level with our personal coaching, with our IIT JEE workshops, expert guidelines, study planner and test analysis. We have one of the best teams for your JEE preparation. We have IITians, NITians and head of coaching institutes on our JEE English team. So make sure you're also attending this lecture and clicking on that bell notification and the subscribe button, and like and share this video because it's anyway free of cost, full length lecture. So do share it with your friends on your social media, students. And that being said, on Unacademy subscription right now, we have started Manzil batch on 24th of December and JEE rank booster. Okay, we are yet to start, so make sure you get it on time and apply Murli Live code. And on 24th of December, we are also starting rank booster 2.1 course batch started by our best educators on Unacademy platform. And that being said, do not forget to like and share this video because it's a free of cost, full length quality lectures for your JEE preparation. And do not forget to hit on that subscribe button, bell notification, so that you can get timely updates. Do definitely share it on your social media like WhatsApp, Facebook, Google groups and Facebook groups, and of course Twitter, etc. And that being said, students, yes, do share it. Keep smiling. See you in the next class. I will see you in the next class at 7:30, which is going to be on current and electricity. So don't miss it out. One of the most important topics and the easiest topic ever that you will come across. Trust me, students, it's going to be the easiest one. So tonight at 7:30, that's the next 5 to 6 minutes. See you in the next class.